Parts Express, the #1 source for audio, video, and speaker building components.
Hi, I'm Joe with Parts Express. Today I'd like to introduce the new DATS, the Dayton Audio Test System. It's a powerful, versatile tool for building better loudspeakers. The DATS makes a quantum leap in terms of the features and ease of use, making it the best toolkit available for testing and perfecting your loudspeaker designs. The DATS pulls more than 30,000 data points in just a few seconds, creating precise impedance measurements and allowing for extremely accurate driver parameters. All the software you'll need is included, and it's compatible with Windows XP, Vista, or 7. There's lots of different parameters you can measure with the DATS. In addition to teal small parameters for a given speaker driver, you can also test for resistance, impedance, or capacitance, as well as rub and buzz testing for new drivers. I'd like to show you how to install the DATS system on your computer. It's really critical that you get this right. We're going to show you how to do it for Windows 7, but there are instructions with the DATS on how to set it up for Windows XP or Windows Vista. If you run into trouble, chances are it's going to be here. First, you'll want to install the DATS CD into your PC. The setup will run automatically. Follow the on-screen instructions to install the software. Then, plug the DATS hardware into a USB port and wait at least 90 seconds for the unit to stabilize. Click on the Windows Start button, open the control panel, open the Hardware and Sound window, then click Manage Audio Devices under Sound. Open the Recording tab, then open USB Audio Device to access microphone properties. Click on the Advanced tab and select 2-channel, 16-bit, 44,100 Hz CD quality. Click Apply. Open the Levels tab and set level value to 1. Click OK to accept changes and close Properties window. Then close the Sound Control panel. Return to the Hardware and Sound window in the Control panel. Under Sound, click Adjust System Volume and raise the computer's volume control to its maximum setting. At this point, we're almost ready to use the DATS, but we still need to calibrate it. To calibrate the test leads, open the DATS Impedance Analyzer menu. Select Test Lead Calibration, then clip the two leads together. Click OK to calibrate the software. In the bottom right of the DATS window, the test lead resistance should read less than 1 ohm. If it reads more than 1 ohm, wait at least 90 more seconds and then try to calibrate it again. If the test leads don't calibrate properly, select Impedance Calibration, then click Restore Default Calibration and repeat the process. The next step will be to use this 1 kilo ohm resistor that came with the DATS system. Again, open the Impedance Analyzer menu and select Impedance Calibration. Follow the on-screen instructions to use the resistor to calibrate the system at 1 kilo ohm. When the calibrated impedance is displayed, make sure it falls between 950 and 1050 ohms. Now, we're finally ready to get started. Today, to demo the DATS, we're going to be using one of the new Dayton Audio Designer Series drivers. You'll notice that this driver has a vented pull piece. That means it's really important to get the driver up in the air so that there's airflow around that pull piece while we're testing. We're going to use some wood blocks. Before you connect your alligator clips, make sure that the speaker isn't attached to anything, amplifiers, other electrical equipment, or ground. We'll go ahead and we'll take the positive alligator clip and the negative alligator clip and hook them up to the appropriate speaker terminals. Now we'll hit the button that says Measure Free Air Parameters. You'll hear a sweep sound. And then you should see a nice smooth plot for impedance and phase. You'll also see on the right-hand side of the DATS window that a lot of the measured teal small parameters have been filled in. We still need to measure the VAS though, and there are several ways we can do that. The first thing to do in measuring the VAS is to find out the piston diameter. This is really simple. All you have to do is take a ruler and measure the diameter of the driver from the apex of the surround to the apex of the surround. We've measured about 21.5 centimeters or 215 millimeters. So we'll go ahead and enter in 215 millimeters as the piston diameter. Now that we've got the piston diameter measured, there are 4 different ways to measure the VAS. There's the test box method, which really is only going to be used for very large drivers where the others are impractical. Next up, we've got the added mass method, which is what most of you will be using at home. Third, the specified SPL method. This is probably the least accurate, and we'd suggest it as a last resort. Lastly, we've got the specified MMD. This is for driver manufacturers who know the moving mass of their diaphragms. We're going to use the added mass method. We actually recommend a roll of masking tape because it's a nice circular weight that's going to sit securely on the driver. It's kind of tacky on the bottom, and we can figure out how much it weighs with a digital scale. $238.4 grams. We'll go ahead and we'll set the tape centered on the cone of the driver, and we'll enter in 238.4 grams. Then we'll hit the button that says Measure VAS, click OK. We've measured the VAS at 2.814 cubic feet. That's within 5% of Dayton Audio's published specification on this driver of 2.99 cubic feet, so I feel pretty good about that measurement. Now that we've finished measuring, we have several options we can use for the data. We can save the data to one of 20 project memories. We can save a DATS project file, which includes your test setup and all 20 memories. Or we can export these parameters and impedance data to either a TXT or ZMA format. We can overlay impedance measurements from up to 20 memories using the DATS software. This makes it extremely easy to make detailed comparisons. And we can print out a report of the displayed impedance and parameters. When you close the DATS hardware, it's going to save all your application settings for your next session. The process is even simpler in future sessions. Just plug in the DATS hardware to your USB port, turn the master volume on your PC to maximum, and then open the DATS software. Since the software saves your settings, you don't have to test the calibration, but it's good practice to sweep the resistor first and double check that the system is still correctly calibrated. With measurements for impedance and phase, as well as all your TL small parameters, it's going to be really easy to use your favorite box or crossover design software to be able to figure out your enclosure or your filters. As you can see, the Dayton Audio Test System is a powerful tool for the speaker building enthusiast. It's sure to become a faithful companion on your audiophile journey. Check it out at partsexpress.com. If you have any questions or ever need technical assistance, our tech support staff is available to live chat on our website or take your call at 1-800-338-0531.
Over 15,000 products, free same-day shipping on most orders, 45-day no-hassle returns, and free tech support. PartsExpress.com, the #1 source for audio, video, and speaker building components. Parts Express, the #1 source for audio, video, and speaker building components.
Hi, I'm Joe with Parts Express. Today I'd like to introduce the new DATS, the Dayton Audio Test System. It's a powerful, versatile tool for building better loudspeakers. The DATS makes a quantum leap in terms of the features and ease of use, making it the best toolkit available for testing and perfecting your loudspeaker designs. The DATS pulls more than 30,000 data points in just a few seconds, creating precise impedance measurements and allowing for extremely accurate driver parameters. All the software you'll need is included, and it's compatible with Windows XP, Vista, or 7. There's lots of different parameters you can measure with the DATS. In addition to TL small parameters for a given speaker driver, you can also test for resistance, impedance, or capacitance, as well as rub and buzz testing